All right, this is the video for Keeping It Fresh Chapter 4. The first few problems there are from our very first section, 1.1. So you're just finding the value of the expression. Remember, that basically means just answer the expression. We don't say solve because it's not an equation. So your first one there, 1, you have 3,963 plus 2,379. 3 plus 9 is 12. 1 plus 6 is 7. Plus 7 is 14. 1 plus 9 is 10, plus 3 is 13. 1 plus 3 is 4, plus 2 is 6. So that'd be 6,342. Next one, you're subtracting. So you've got 6,184 minus 2,348. Can't take 8 away from 4, so we need to borrow from this 8 and make it a 7. Make this a 14. 14 minus 8 is 6. 7 minus 4 is 3. I can't do 1 minus 3, so I'm going to borrow from the 6. Make this 11. 11 minus 3 is 8, and 5 minus 2 is 3. So 3,836. Next, we've got 184 times 26. 4 times 6 is 24. 8 times 6 is 48, plus 2 is 50. 1 times 6 is 6, plus 5 is 11. We need a 0 for the second row. 4 times 2 is 8. 8 times 2 is 16. 1 times 2 is 2, plus 1 is 3. So that gives us 4,784. And then we have a dividing problem. So 207 divided by 23. Remember, when it's written that way, 207 is your dividend, the one that goes underneath the division sign. 23 is your divisor, the one that goes outside. So 23 can't go into 2, can't go into 20, so you've just got to figure out how many times does 23 go into 207. Well, 23 times 10 would be 230, so, and I know I can't use 10, so 9 seems like the logical place to start. 9 times 3 is 27, 9 times 2 is 18, plus 2 would be 20. So that is 207. So our answer is 9. The next few here are just determine whether the number is a perfect square or not. Now, perfect square is a number you get when you square or raise to the second power a whole number. So like 2 squared is 4. 4 is a perfect square because it's the result I get when I do 2 to the second power. 3 to the second power is 9, so 9 is a perfect square. 4 to the second power is 16, so 16 is a perfect square. So all these numbers here, the answers I'm getting when I square a whole number is a perfect square. So what you want to ask yourself here when they give you the answer is ask yourself, is there a number times itself that equals 88? And you could just keep making this list. So you could do 5 squared is 25, 6 squared is 36, and keep going until you get close to 88. So if I keep going here, 7 squared is 49. See, I can bump this out of the way. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. So 88 is 88 in my list, and I know these are a little hard to read, but hopefully you can see them well enough. No, it's not. 81 and then 100. 88 would fall somewhere in between here, so that means there's no whole number multiplied by itself that equals 88. So the answer here would be no. Is 121 on my list? Yes, it is. It's 11 squared, so 121 is a perfect square. This is order of operations. Remember, a number next parenthesis means multiplication. I want to do parentheses first, so remember it's please excuse my dear Aunt Sally. So I'm going to have 8 and then a parentheses, 3 plus 4 is 7 divided by 7. Then I want to multiply the top here. 8 times 7 is 56. And remember, a number written as a fraction means division. So 56 divided by 7 is 8. Prime factorization means prime tree. So take that number 32 and come up with 2 numbers that multiply to 32. A good option would be 4 and 8, but 16 and 2 would work as well. And then I check, are these numbers prime? 4 is not, so I need to break it up further, and 8 is not either. 4 I can break up into 2 times 2, 8 I can break up into 4 times 2. Now I check again for prime numbers. Well, 2 is prime, so that means I'm going to circle all the 2's. But 4 is not, so I need to break it up again into 2 and 2, which is prime. So that means 2 times 2 times 2 times 2 times 2 equals 32. I'm going to write that using exponents. 2 would be my base, and I have 1, 2, 3, 4, 5 2s. So 2 to the 5th power is my answer there. 1.5, you have 60 chocolate chip cookies and 75 monster cookies. You want to make the greatest number of cookie bags with no remaining cookies. How many cookie bags can you make? So they're asking us to find GCF of 60 and 75. Remember, you can use the cake method for that. So what's a number that divides into 60 and 75? Well, think about my divisibility rules. This ends in 0, this ends in 5. So now I could divide them both by 5. 60 divided by 5 is 12. 75 divided by 5 is 15. I want to check again. Is there a number I can divide into both 12 and 15? And there is. It's 3. 3 divides into 12 4 times. 3 divides into 15 5 times. Is there a number I can divide into 4 and 5? Well, other than 1, no. So remember, GCF is your numbers on the side multiplied together. A lot of you guys have asked me for help on GCF and LCM on all these keeping it freshes. It keeps popping up because it's something you got to know, and it's something that eventually you need to be able to know without asking me. So multiply those numbers on the side. If it was LCM, I would multiply these numbers and these numbers on the bottom. So I do 5 times 3 times 4 times 5. So I can make 15 bags. Don't forget your label. All right, LCM, we just talked about it. Maybe you were paying attention and you'll know how to do it. So find the LCM of 50 and 100. You can still use cake. Both those numbers end in 0, so if you didn't realize that you could divide them both by 50, then maybe you start with 10. 10 divides into 50 5 times and into 100 10 times. And then maybe now you realize, oh, I can divide those both by 5. 5 divides into 5 1 time and into 10 2 times. LCM, like we talked about on the last page, is the numbers on the side and the bottom multiplied together. It makes an L. So 10 times 5 times 1 times 2. So I'd probably break it up into 2 groups here. 10 times 5 is 50. 1 times 2 is 2. So 50 times 2 is 100. So in this case, the LCM is the bigger of our 2 numbers, and that's okay. All right, number 11. We have 2 2/3 times 4/5. I'm going to scoot some of this out of the way here just so we have room. We need to make that 2 2/3 into an improper fraction. So 2 times 3 is 6 plus 2 is 8. So 8/3 times 4/5. Remember, you just multiply straight across. So 8 times 4 is 32. 3 times 5 is 15. You check to see if it's simplified. Is there a number I can divide into 32 and 15? Well, there's not. So you could leave it like this, or you can make it a mixed number. 15 goes into 32 2 times, because 15 times 2 is 30, which means there would be 2 left over. So 2 and 2/15 would be the mixed number answer. Either of those answers is fine. 2.3, 4 1/8 divided by 2 1/4. We need to make these both improper first. So 4 times 8 is 32, plus 1 is 33. Still division for right now, because all I'm doing is making them improper fractions. 2 times 4 is 8, plus 1 is 9. Now I can do skip times flip, which means 33 over 8 is going to stay 33 over 8, skip. This is going to become times, and this is going to get flipped. Now we could do some cross-reducing here. I can divide both 4 and 8 by 4, so that would make this 1 and this 2. And actually I could divide these both by 3, but I'll bet some people missed that, so maybe you didn't reduce all the way at the end here. 9 divided by 3 is 3. 33 divided by 3 is 11. So 11 times 1 is 11. 2 times 3 is 6. That's a simplified improper fraction, or you could make it a mixed number. That would be 1 and 5/6. Decimals. So 14 and 21/100 minus 4 and 103 thousandths. Remember, the key to adding and subtracting decimals is the decimal point must be lined up, which means in this case I'll need to add in a placeholder 0 for my first number. And it has to go with subtraction, it has to go in order. So whatever number came first on the left has to be the number on top. You can't just take the longer number and put that first. So 0 minus 3 doesn't work, so I'm going to have to borrow from the 1, make that a 0, make this a 10. 10 minus 3 is 7. 0 minus 0 does work, that's 0. 2 minus 1 is 1. The decimal point just gets brought down to the same spot in the answer. 4 minus 4 is 0. And 1 minus, you could put in a placeholder 0 here if you want as well. 1 minus 0 is 1. So 10 and 107 thousandths is our answer there. 14, multiplying decimals. Remember, we can treat this as if it's like 442 and 27. We just ignore the decimals while we multiply. So 442 times 27. 2 times 7 is 14. 4 times 7 is 28, plus 1 is 29. 4 times 7 again is 28, plus 2 is 30. And then 0. 2 times 2 is 4. 4 times 2 is 8. And 4 times 2 is 8. So when we add that all up, we get 11934. Remember, with multiplying, go ahead and put your decimal back in now that we've multiplied and figure out where it goes in your answer. It doesn't line up. It's not like this where it just comes straight down. I asked myself how many numbers were behind the decimal. There were 1, 2, 3 numbers behind the decimal. So starting from the back, 1, 2, 3 means my answer is 11 and 934 thousandths. Dividing, we have 9 and 32 hundredths divided by 4. Our divisor has to be whole number, and it is, so great. That means the decimal stays where it is here in the dividend and just gets pushed up to the same spot in the quotient. And then I divide like normal. So 4 goes into 9 twice, giving me 8. 4 goes into 13 4 times. Not 4 times. There we go, 3 times. And then 4 goes into 12 3 times. So 2 and 33 hundredths is our answer for number 15. All right, just some vocab, really, from chapter 3. So we have the expression 5p plus w minus 6 and 2/10. It says how many terms are in the expression above. There are 3 terms. Remember, terms are separated by plus and minus signs. So 5p is a term, w is a term, and 6.2 is a term. What's the variable or variables? That's why it's in parentheses there, because it could be more than one in the expression above. There's 2 variables. There's p and w are the variables. What's the constant in the expression above? The constant would be the 6 and 2/10. And what's the coefficients in the expression above? Since there were 2 variables, that means there's 2 coefficients. 5 is the coefficient of the p, and 1 is the coefficient of the w. Remember, if you don't see a number in front of the variable, that number in front of it is a 1. 3.2, write the phrase as an expression. 25 less than a number b. A number AB. Oops, that's a typo there. That should just be a number B. Less than means subtraction, but remember, reverses the order of the sentence. So it is not just 25 minus B like it's written in the sentence. It's saying 25 less than B, so 25 being taken away from B. So it should be this, B minus 25. 21 is a number x divided by 4. This is the preferred way of us writing x divided by 4 now that we're moving into working with equations. But if you wrote x and then division sign 4 like this, or a slash, or technically even this would be okay. Simplify by combining like terms. So we need to do some distributing and then find which ones are alike. So remember, a number next to parentheses that has an adding or subtracting expression means I can do this, 4 times x and 4 times 3. So 4 times x is 4x. I rewrite that plus sign. 4 times 3 is 12, and I'm going to rewrite everything else that was in that expression. Now I've got some like terms here. 4x and plus 2x go together, and plus 12 and minus 8 go together. So I'm going to rewrite that so that they're next to each other. So 4x plus 2x plus 12 minus 8. 4x plus 2x is 6x, 12 minus 8 is 4. So 6x plus 4 is our expression. 21, find the area of a parallelogram. The area of a parallelogram is base times height. So we would do 20 times 25. You can use a little bit of a trick here. Since 20 ends in a 0, you can write it like this. Just bring that 0 on down. 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. So that'd be 500. Don't forget your units. Yards squared. Area is always the units squared. Find the area of the triangle. Area formula of a triangle is base times height, but divided by 2. Don't forget the divided by 2 part. So your base and height are 7 and 10. 7 times 10 is 70. 70 divided by 2 is 35, and your units would be miles squared. Find the area of the trapezoid, and I didn't draw it for you, but you don't really need the picture as long as you know the formula. Area formula for a trapezoid is base 1 plus base 2 times the height, and all of that is divided by 2. So my base 1 is 15, my base 2 is 6, my height's 10. Follow order of operations. 15 plus 6 is 21. 21 times 10 is 210. 210 divided by 2. Well, 200 divided by 2 would be 100. 10 divided by 2 would be 5. So 105 meters squared. And then this is a composite shape, not a trapezoid. If you count it, it has 1, 2, 3, 4, 5, 6 sides. A trapezoid only has 4 sides. Now you can split it up into a trapezoid on top and a rectangle on the bottom, but you can't just treat this as a trapezoid. So if we look at the trapezoidal part here, we just did one. So remember the formula is base 1 plus base 2 times the height divided by 2. Well, my base would be 6, and then this would be my other base. Well, how long is that? Well, it's 10, because it's parallel to that line there. So my base 1 and base 2 are 6 and 10. What's my height? My height would be the distance between the two bases, and it has to be a straight line, not a slanted line. Well, it shows that this is the straight line distance between those two, and that's 5. So 6 plus 10 is 16. 16 times 5 is 80. 80 divided by 2 is 40. So I know the area of the trapezoid up here is 40. Rectangle should be easy, because that's just base times height. And I can see that my base and height are 5 and 10. So 5 times 10 is 50. So that's the area of my rectangle. Remember, composite shapes, you add the areas together. So 40 plus 50 means my composite area is 90, and I need my units inches squared. And that's our keeping it fresh.